All right, welcome to organic chemistry, also known as the best chemistry. Make sure you know that, it'll be on the test. Let's start off at the beginning of inorganic chemistry versus organic chemistry. And so back in the day, inorganic chemistry was kind of thought to be about things that are not alive. And then organic chemistry was considered the kind of chemistry of life. So things that are alive. And if you think about it, those two things generally have pretty different properties. So for example, take like an iron bar maybe. Back in the day, or even right now, right, you could add some heat to it, you could melt it down, and then cool it back down and maybe like form a sword or something, or whatever the heck you wanted to make. And so generally inorganic things or not alive things, they can withstand extreme conditions. So you can take a rock, put it into a fire, and it's perfectly fine. Nothing really happens to it. Let's take a look at something alive, maybe something like a log. And what happens when you put that into a fire and heat it up? Well, it's going to basically just burn and turn into kind of a black pile of char. And so organic things can't withstand these extreme conditions. And so back in the day, they thought that there was two separate types of chemistry, that there was the chemistry of things that are not alive, and then the chemistry of things that are alive. Since then, we've learned that's not true, and that basically chemistry is one science and it governs both sides. And so if you think about your kind of knowledge of chemistry and whatnot, if you look at these inorganic compounds, what you'll see is it's for the most part ionic and metallic bonding. While the kind of chemistry of life or organic chemistry is basically mostly covalent carbon-based bonding. And so it's this difference that kind of makes these two chemistries relatively different from one another, but at the end of the day, they're still both chemistry.